Up next here, we have we're going to talk about the area of a parallelogram. So area of two L's. Parallelogram. Let me get rid of that thing. So we're talking about the area of a parallelogram. First, we got to make sure we understand what a parallelogram is. So let me go in red here, and just for fun, let me draw a rectangle. So if we have a rectangle here, and let's say we take this top side of the rectangle and shift it over to the right 1 unit, 1 foot or 1 inch, whatever we're talking about here. So let's do that. Let me show that with this. So here I've taken the whole thing and shifted it over 1 unit. So now we have connected these figures. I have that figure here in blue, and that is a parallelogram. That is, you take one side of a rectangle, top side or bottom side, and shift it to the right or left. So I shifted this thing to the right. And the cool thing here from this picture is it makes it really obvious. When I did that, so I had the area of my rectangle there. I'm talking about the area, the space this thing occupies now. When I did that shift, I see that I got an additional bit of area here, this triangle. But guess what? I lost I lost this area over here. I lost the same amount. So it turns out that the area of a parallelogram is going to be equals the base right here times height. So it's just like the area of a rectangle. Length times width, base times height. Doesn't matter. Either way you want to call it. So it's going to be the base. Again, this is really important to make it make sense here. So you have to remember less when things make sense to you. So we slid that top piece over, and we noticed that we got some additional area outside of the original rectangle. But we look over here and we see that we lost the same amount inside the rectangle. So the area remained the same. So the area is the same as the rectangle. So the rectangle is going to be, we would have called it typically been width or length times width. But now, typically when you're talking about things other than rectangles, you talk about base and height. So the area of the parallelogram is the base times the height. So let me get rid of that one. Let's do it all again. So we have a parallelogram here. And then let's start this one. Okay. We'll call this the base. Call this the height. And we get that the area is just like a rectangle. Area equals base times height. So let's say that this thing has a base of, let's say 2 miles. We haven't talked about miles yet. Let's not say 2. We got a phone call. Who's that? That is the wife. I will call her back. How do I make this thing stop ringing? I'm making a podcast here. Stop calling. I think that was my wife. Yes. Okay. So, I'll call her back. Don't worry. So let's say the base is 15. We have 15 miles. And let's say we have a height here of, if that's 15, what's that thing look like? About, I don't know, 3 miles. So the area of this parallelogram is going to be 3 miles well, let me do the order that I said there. So let me base. It will be base times height, which equals 15 miles times 3 miles. 3 times 15. We should be able to do that, but just to make sure we're okay with the calculator, let's use it a few times. Clear everything out. 15 times 3. We should get 45. Alright, let's see, we're getting 45 there. And we know that a mile times a mile is a square mile. Square miles. And again, I want to emphasize what this means. This region right here is the space that this parallelogram occupies is 45 square miles. Of course, it's not drawn to scale there. What that means, though, is that if we had a square mile, 1 mile long, 1 mile wide, this is one, this is one, we could fit 45 of these into this space of a parallelogram with a base of 15 miles and a height of 3 miles. Again, very important to understand what this area business is. That is exactly what it is. It's how many of these little square blocks can we fit, square in unit squares, 1 mile can we fit into the space that we're looking at. And that will do it for the definition here of the area of parallelogram.